We are about to start with our first technical session, and this session, as per the schedule, will be taken care by our expert speaker in the field of natural language processing, Dr. Joyanta Basu. He is the scientist E in the at CDEC, Kolkata. So, sir, over to you.
Thank you. Thank you, John. Am I audible? Yes. So it's better to, speak without mic. Thank you, Joyanta, and thank you all of you. So, about my topic, my background is basically an electronics engineer. Mostly work in the area of audio signal processing, as well as textual signal processing. Textual means whatever I am speaking is audio, whatever I am writing or reading is a text. Okay. So everything and whatever we will do in CDAC, it's basically either input is a speech or text or output is a speech or text. Understood that point? As an IT or computer science engineer, you know what is the input and output of the system first. So my area of research, either input is a speech or text, or my output is either speech or text. Understood? Whatever we will do in between, maybe some machine learning, maybe some statistical modeling, maybe some kind of rule-based modeling, maybe some others. Okay. So just move forward. So as I already mentioned, I am from Center for Development of Advanced Computing. It's under Ministry of Electronics and Information Technology, Government of India. We started our journey since 1988. We have 12 centers around India, and we currently have more than 3,000 professionals working in this organization. And I am from Kolkata. So these are the different thematic areas where we are working, not me. As a whole CDAC, we are working. I will take only 1 minute or 2 minutes. High performance computing. This is basically HPC. Multilingual computing and digital preservation. That is my area of work. Part of the area. Professional electronics including VLSI and embedded systems. Software technology including POS, cybersecurity, cyber forensic, health information, and education and training. So these are major 7 areas mostly CDAC are working. Okay. So these are the different expertise. I'm just skipping. This is the CDAC Kolkata building where we are working. And okay, now come to the point of the area where I'm working. So as you all know, India is a rich cultural heritage. There are many languages we speak. I already mentioned in my introductory talk. 28 states, 8 union territories, 140 crores population. There are 19,500 language and dialects all over the India. Can you imagine the number? 19,000, more than 19,000 dialects are there. Okay, and only there are 123 major languages, of which 30 are spoken. Within which these 123 major languages, within which the 30 major languages spoken more than 1 million of native speakers. Okay, so whatever the statistics is showing, the majority of the language and dialects, whatever there in India, the spoken by very small amount of people. Okay, very small amount of people, they speak on those very specific languages. And according to this 2011 census, 43.63% speakers can speak or understand Hindi. Okay, 8% speaker Bengali, Marathi maybe 6-7%, Telugu this way. Okay, these are all statistics available. But the point is, from the introductory slide, is that India is a huge, cultural heritage. If you see, there are many languages and dialects all over the India, and we know as a human being only 2-3 languages. Like me, I know maybe 3 languages. You may know like 4 languages. How? English, Hindi, maybe your native language, and some kind of common lingua franca. Like one people in Nagaland, they can speak at least 4 languages. How? If they are tribal language, they know the own tribal language, they know the common lingua franca, that is Nagamese, as well as they know English and Hindi. So try to understand the child who is, at the age of 5 or 6, they need, whenever they go to interact with the people, they need to learn other languages apart from the native language. The challenges start from the very childhood. And whenever this child, come forward and interact with the people of the city, okay, they need to know about the English or maybe the Hindi. Maybe the Nagamese they can know, because all the people in the Nagaland, they can speak, they can understand Nagamese. But the child, they know Ao also, Lotha also, maybe Ao, Lotha, Sumi, Ongami. There are many languages and tribes in there. So in India, like country, each and every person may know at least 2 to 3 languages, maybe more. And I have some kind of voice samples for playing. Okay, so the intention is that I will play some audio file if it is played at all. Okay, your objective is to try to understand who is the speaker. That is my question. Who is the speaker behind this? This audio file, that you need to find out. This is my simple question. Okay, so I'm trying to play one by one. Number 1, I am playing.
किनारों से बढ़कर मौका पार नहीं होती, कोशिश करने वालों की कभी हार नहीं होती। किनारों से बढ़कर मौका पार नहीं होती, कोशिश करने वालों की कभी हार नहीं होती।
Thank you. So that is one audio file I played. Maybe you have some kind of perception who is the speaker. Okay, just hold your answer first. Number 2, I am playing.
Today's event is about education and technology. More specifically, it is about empowering the students of today to create the world of tomorrow.
Number 2, try and guess. Okay.
There's an important inflection point in computing, and it's exciting to be driving technology forward. And it's made us even more reflective about our responsibilities.
Number 4, I'm playing.
फ्रेंड वो समय है जब टेक्नोलॉजी के बिना जीवन की कल्पना करना मुश्किल है।
I think
आज
100%
कहीं
of the
कोई
audience can understand. Okay.
हर व्यक्ति का जीवन टेक्नोलॉजी से किसी न किसी रूप में जुड़ा हुआ है।
Number 5, I'm playing.
My administration has accomplished more than almost any administration in the history of our country.
Number 6,
So you can use your power to build rounds and keep people outside. Or you may use it to raid barriers and waken them in. You may use your faith to make people afraid and terrify them into submission.
Okay, number 7.
Life is not so simple, is it? We have to handle the failures with stone heart.
Number 8.
Chandrayaan was India's first lunar probe.
So these are the 8 samples I have already played. Number 1, who is the speaker? Any idea? Okay. Number 2. I can play again. Should I play again? Number 2.
Yes.
Okay.
Today's event is about education and technology. More specifically, it is about empowering the students of today to create the world of tomorrow.
Maybe it's little difficult. Huh? Who? No. But good guess. Anyway, I'm number 3. No, Elon Musk is not correct. Okay, number 4. Number 5. Number 6. Who is saying? Okay, anybody else? Anybody else? Okay, 7. 7. What's his name? Okay. So, my intention, I have played some audio file, and you are trying to gauge the speaker. Now, I'm trying to give you some clue. What is a clue? Visual clue. So maybe these are the speakers. Okay. Now you try to match. Now little bit easy for you. Already, you recognize like a few audio files and already mapped. Maybe some correct, some may not be correct. So now, can you please guess? Modi is 100% correct, and Trump is 100% correct. Then SRK, you mentioned is what is also here. Okay.
3 Sundar Pichai.
So anybody please try again. Number 1, who is the speaker? Amitabh Bachchan, correct. Number 2. Number 2. Satyanadala. Okay. Anybody else? Huh? Sundar Pichai. Okay. Well guess. Number 3.
Sundar Pichai.
Sundar Pichai. Good. So number 2 and number 3, the speaker may be Sundar Pichai or maybe Satyanadala. Okay. As per the audience. Okay. And number 4, our Prime Minister. 5, Donald Trump, I think so. 6, who is the speaker? SRK. Okay, fine. 7. They're only trying to minimize the search space and try to map. That's okay. As in computer science engineer, that's we do better. Okay. So already reduce the search map and we try to map. Okay, good. And number 8, maybe some unknown faces are there. So anyway, well tried. And the answer is something like that. So Amitabh Bachchan, Satyanadala, Sundar Pichai, our Prime Minister, Donald Trump, Shah Rukh, SRK, APJ Abdul Kalam, then some unknown voice. Okay. So why I played this audio file in front of you, and I have given some visual cues. Only try to map each and every audio. There are maybe some person is involved. Okay. And if our brain is already trained with the audio file, of that particular speaker, then I maybe understand who is speaking. Like Satyanadala and Sundar Pichai, these are 2 Indians, but they are speaking in such a way they are not truly Indian as in English. Some foreign accents. So that's why Sultan Azala or maybe either of them. But it's a correct. From the way of speaking, like I say, how we speak, when I am speaking in Bengali, maybe I am more fluent than English. Okay? And my friends, they can more understand whenever I am speaking in Bengali, may not be English or Hindi. Okay? So language is important. Language is maybe some barrier to understand one speaker. Why this SRK voice is not so good, and maybe some one person they only understand this is SRK. But when I play some movie clip, okay, or maybe some any Hindi voice of SRK, then maybe 100% of the audience can recognize this is SRK. So language and the speaker, it's not correlated. I mean, every time we listen like a Shah Rukh Khan for the Hindi movie only, so we never listen like an English lecture of Shah Rukh Khan. It's unnatural. I know the speaker, but somehow I cannot relate these two speakers. So that already I mentioned, whenever I speak in Bengali, maybe it's better to understand by my friends, my family. Whenever I speak in English or Hindi, may not be. Okay. The same case for the SRK here. And number 7, nobody answered correctly on the matching we have done. Like this is our Prime Minister, 11th Prime Minister. APJ Abdul Kalam. Why? Because nobody can listen any speech of this particular speech speaker. If we listen, maybe it's only for 5 to 10 minutes. I've already forgotten. Whatever I have listened, the way of speaking of APJ Abdul Kalam, I forgot. That's why. So this is the audio file is not registered in our human brain. Understand my point? So similarly, I have already given some unknown one. I also don't know who is the speaker. Sometimes when somebody is calling some unknown number to my mobile, I try to understand, hello, who is this? And my brain starts working like who is the speaker behind? Is it my friend, some relative, some spam call or something like that? So I say, who is speaking? So if the other side, the speaker is saying, oh, you don't know, you are my childhood friend. So immediately my search space is going to reduce my native space, my very close friends, and some visuals are coming in my mind. Like here also, like my friend is maybe Oil, maybe some Bappa, or maybe some Shokosachi, maybe some Oru, maybe Tulika. There are different names will come in my mind. Or maybe some kind of male or female also. I try to, okay, is this a male voice or female voice? Okay, try to understand. I mean, when there's an unknown voice and call is coming, we also think in such a way, okay, it's a female voice. Or maybe it's some female childhood friend. So try to register who are those childhood friends. Then try to map. Our brain is weak. Okay? So these unknown voice, we also don't know who is the speaker, and it's not registered in our mind. So we cannot understand or recognize the speaker. Whatever I am saying, human brain is machine. Our thinking is our machine learning process. Okay? Okay. Another way, I am not playing, but I am saying this is also the language games. I can play different language. Maybe you can also try 2, 3. I mean, we will try. This time the problem is I am going to play again some 8 or 9 audio file to try to understand the name of the language. Hindi, Tamil, Telugu, Urdu, Assamese. What is that? Okay. Number 2. Maybe it's little difficult. So these are some answers. I'm not saying, but the problem is something like that. What are the most important information I captured from those audio files? So that's the question. Like a speaker information, emotions. Like I am speaking in such a way, my emotion is like happy mood. Whenever the Shah Rukh Khan or maybe Amitabh Bachchan is speaking in different mood. Okay. So emotion, language. Again, Shadukhan spoke in Hindi mostly, but here in English. Okay, accent, speech content. What is speaking? Okay, in English, what is the content? Who spoke when? There is kind of diarization kind of problem, and there are many more things. These are all information we can capture from the audio file, and we can extract that information, and we build the system. As a computer science engineer, as an IT expert, we can develop such a solution. If I can develop a problem where my input like this kind of audio file, audio sound, I try to understand or try to, try to do some kind of problem statement where I try to understand speaker information, emotion of the speech, angry, happy, sad, something like that. Because each and every time the emotions are different. Like whatever I am speaking is more or less neutral. Not I am really happy mood, not I am very angry mood. But whenever I am happy, my intonation pattern will be different. Okay? So language, speech, and there are many things are there. So these are the important point I try to mention over here. And as an IT engineer, as a CSE person, you can develop different AI ML or different application to cater this kind of problem. Understand my point? These are my introductory slides. Try to give you some flavor in which area I am working, what are the problem statements, and why these are very important and very language specific. It's a language specific problem. It's not like that if I solve the problem in Bengali, I can solve the problem in Nepali or some other language or maybe the Kokborok. It's not like that. Each and every language, they have their own beauty, own signature within the audio file as well as textual content. Understood? So we need to understand those language, and as an engineer, as an engineer of that area, we can develop some kind of solution for this. Okay. So this is very important. Okay, data. We are data hungry people. Okay, every time I'm saying I cannot do my research because I don't have the data. It's true. It's true. Very true. Without data, we cannot start. Without data, we cannot start. So there are different types of data. Like whatever I'm speaking, like this is this data is basically audio data. Audio data is 2, 3. This is kind of trading data, share market data. That is also natural data. Okay, you can say. This is IMD data, meteorological data, weather information, rain information. These are all changing information. It's not varying. It's a varying. Sorry, it's a varying information. Okay, like a forecasting. So that is also some kind of prediction algorithms also there. Okay, these are kind of visuals like a face. As a face, currently you are registering my face. Okay, this is Joyanta from CDEC. So you are registering my face. Okay, as well as audio. Some number plates. That is also the data. But we are little familiar with this kind of data, this Excel data. So whatever I initially showed, these are all natural data, raw data. But if we can extract features or different parameters from the raw data, and it can be tabulated in kind of CSV file, then I am happy as a data science engineer. Because I have the data right now in CSV format, I can run 10 classification problem. I have different algorithms in my mind. I can run and I can solve the problem, different classification problem. It is a identification of speaker, identification of the facial expression, different problem I can solve if I have this CSV kind of data in my hand. Is it correct? So I think all of you are working in the IT area and you are little habituated with the machine learning based algorithms also you are learning. You are doing some kind of programming in Python where you are trying to import CSV file. Am I correct? Is it true? But where where this Excel file are generated? From where this Excel data is generated? From the raw data. From raw data to this CSV file generation, we call it domain expertise. raw data to this kind of Excel data. If I am the expert in vision domain, so I have different X and Y coordinate pixel values. These are raw data in image processing. So I can extract those information, important information we call as a feature, and make Excel file. Understood my problem? I mean my points? So each and everybody as a student, we are trying to extract the feature of any kind of real-time data, raw data, to kind of extracted information or feature information that is in the CSV file. So, and this transformation is required the domain expertise on that particular area. But in the day of like a neural network, it will take like a 7 days only. You will take to get some kind of information, extract the information. To learn little bit on neural network, you can extract any raw data, and this kind of CSV file you can generate. Anyway, okay, I am not going details in speech processing. It's a only part of the AI/ML model, and that's my area. Mostly I am working the audio data processing, where within that, I will say that within the AI, the machine learning is a part of the AI. We all know. Already I mentioned about the speech technology. What is speech? I already mentioned. Whatever I am speaking, I am generating kind of analog signal. You are hearing. This is the production. I am trying to produce the audio file, and your brain try to understand whatever I am trying to say. Okay, that means it's a perception. Production to perception. So what are the different major application in recognition? I already mentioned, like speech recognition means speech to text. If my input is a speech, my output is a text. That is a speech recognition problem. Speaker recognition, what is that? My input again like a speech, my problem statement, try to understand the speaker. Try to understand the speaker. Is Mr. X, Mrs. Y, or Z, or who is the speaker? Okay. Anyway, speaker recognition is also two-part, speaker identification, speaker verification. I'm not going to the detail of that. Language recognition, try to understand the language. What is, in which language the speaker is speaking? That is my question. Emotion recognition, try to understand the emotion. Synthesis, that is reverse process. And try to give input by system text. I will give to my system as a text as an input, speech as an output. That is text to speech synthesis. That is synthesis system. Speech to speech translation, already our deans are already mentioned one problem statement. Whenever I am speaking in English, you can understand, you can listen in maybe Kokborok, maybe Hindi. So speech is an input and speech as an output. In between there is some kind of mechanism, there are some models. Okay, then we will do source is a source language is English, target language is a Kokborok. Say. So I am speaking in English, so I need English speech recognition, then speech to text, text in the source language, then source to target language, text to text conversion, then text to target language, text to target language, speech conversion. That is the entire process of the speech to speech. Okay. Then manipulation, enhancement, voice mapping, and kind of auditory problem. This kind of ISL is a part of the auditory problem. We are trying to develop some kind of Indian Sign Language. That is a part of this kind of problem. Okay. If we have some kind of speech disorder or maybe hearing disorder for which we are developing some kind of solution for the society, that's a part of this area. Then audio engineering, maybe some kind of these kind of audio engineering, mostly it's kind of entertainment domain. Most of the time it's used like adding some kind of effect. Okay, but then clarity or maybe the enhancement of the speech. These are all part of this audio engineering. Okay, this is some screenshot from taking from Brad software. Right hand side there is a wavefront view. X-axis is the time, Y-axis is the amplitude. Spectral view below. Again, this X-axis is the time, Y-axis is the frequency, and the intensity. this is one important point, that's why I'm taking this slide. We know I am generating analog signal, but whenever I try to record my voice in the device, whenever I am trying to record my voice in device, we actually convert analog signal to a digital format. Understood my point? Whenever I am trying to record my voice, that time I am recording my analog signal to a digital format. And digital format means some kind of numbers. For that we need like a sampling frequency and many. Complexity. There are different complexities we have in this kind of audio signal. We cannot perceive any sound below 40 milliseconds. We cannot perceive. Okay? We cannot understand at all if the duration of the any vowels or any kind of consonant is below 40 seconds. And rate of transmission is syllable. How fast I am speaking, that is important. If I speak very less, okay, that means I am transmitting very less amount of phonemes in a single second. Okay, that is a transmission rate. Okay, this is a production mechanism. And production mechanism, you all know, there is a lung, there are huge muscle folds. There are ears are there in the lung, and it go through vocal cord. There are vocal cords are there. This is the voice box, okay, and this is the vocal folds, and this is the larynx through which we are producing the sound. And there are different kind of cavity. One is a nasal cavity. By nose we can speak also. Some language, the nasal is a very important aspect, okay, and as well as oral cavity. So it's part of the kind of filtering concept. If you read about the filtering concept, it's part of kind of filtering concept. Okay, so it's started from my lung, and its output is basically either mouth or maybe the nose. Okay. Okay. Is that okay? So I'd like to play some kind of video here. This is the production of ko sound. This is the production of ko. K sound, okay, call sound. Just follow the video on. Is it playing? I don't know. What is that? Okay, actually it's taking the feed from the internet. That's why maybe. Okay. I don't know it is also play or not. No problem. No problem. So similarly, this is important slide. Most of the sound or audio file, we have the mostly two sounds, vowel and consonant. Other than vowel and consonant, we have the semi-vowels or diphthongs. Okay. So vowels is O, R, E, U, O. These are vowel, major vowels. I'm not saying these are all five vowels for all languages. There are many other vowels also, but these are major five vowels we produce whenever we are speaking in English mostly. Okay. So these vowels, they have produced the maximum energy. Why? Try to understand and try to feel. Okay. So this is my voice box. Okay. I try to produce some vowels. Or so I just hold my throat, and this is my voice box, and vocal tract and vocal fold is vibrating. Or try to produce and try just Why? Because it's not vibrating, it's like the opening. That's a vocal cord is vibrating in this way manner. It's not vibrating this way. It's a vibrating on this way. So air is passes through the vocal cord only. So no resonance. No, it's a completely noisy sound. It's a completely noisy sound. Whenever we produce the vowels, it's a periodic in nature. We call it a aperiodic signal or a semi-periodic signal or a quasi-periodic signal we can say for the vowels. But most of the consonant, quote unquote, most of the consonant, they don't produce by the vibration of the vocal cord. Obviously vibration, but it's kind of noisy effect. But some sound like a mo, like a ma, mo, you feel some vibration mo, mo, mo. First of all, we cannot produce mo with a. Mo. Try. Mo. Some vibration is there for mo, no, lo, mo. These consonants, they have some resonating frequency and some kind of quasi-periodic nature. Quasi-periodic means some kind of periodicity is there, like a sine wave, like a cos wave. Understood my point? Okay. So another thing here we have seen like a leaf. Our leaf also is taking another important role whenever I produce any kind of vowels, like the O, round shape, A, kind of flat shape. That is also very important at the time of production. But we know everything, but we never try. Okay. So, but these as an engineer, whenever we are trying to understand the domain knowledge and try to produce any kind of solution, you need to understand this small thing. Okay. That's why I am saying only. Similarly, whatever I mentioned, this consonant also. This is segmental and suprasegmental features. What is that? This is like any audio file. We are segmenting here. Like this is a do, this is a or o, this is sho, mo. This way we are segmenting. Some kind of durations are there. Okay. This is a do is some duration, a is a duration, sho is a duration. These are segmental features. But whenever we are doing like a amplitude of pitch, tone, intonation, how way we are speaking. Like a sentence like tumi ki bari jabe. Everybody understand little bit on Bengali? Okay. Tumi ki bari jabe. Tumi ki bari jabe. Tumi bari jabe. So intonation is different. So whenever the intonation is different, this speech profile will be different. Whenever we will plot pitch profile against any audio data, it will be different. And these are the important feature to extract from the audio file and plot it into the CSV. Because our target is to, from the raw data, extract the information, put it into the CSV file so that I can run my machine learning model. Okay, that is my thumb rule. That is we are trying to do. Okay, stress. Okay, we all know the stress.
আমি কাল ভাত খেয়েছি।
In Bengali, আমি কাল ভাত খেয়েছি. Okay.
আমি কাল ভাত খেয়েছি।
The given the trace on kal yesterday, আমি কাল ভাত খেয়েছি. Okay. Third,
আমি কাল ভাত খেয়েছি।
where the trace is bhat. What I have taken. So bhat is the word where given the stress. Why? What is the requirement? Because you are asking the question, তুমি গতকাল কি খেয়েছো? Then আমি গতকাল ভাত খেয়েছি. যদি কোশ্চেনটা if the question is তুমি কি কাল ভাত খেয়েছো? আমি কাল ভাত খেয়েছি. So the question, answer and stress is dependent on the question. What question you are throwing? Okay, so that is also important. You know that one PhD thesis is only on the stress detection. Only on the stress detection from the audio signal. This is a problem statement one. The Jadavpur University scholar, they have taken this problem statement, identifying the stress from the audio file, without independent of any language. The problem statement is the last two words, independent of any language. each and every language they can speak in such a way, stress position is different. Okay, so identifying the stress from the audio data independent of any language, independent of language. Okay, so the PhD thesis can be possible on this problem statement also, identifying the stress. Similarly, pitch, I already mentioned, I can speak in different intonation pattern. তুমি কি কাল ভাত খাবে? তুমি কাল ভাত খাবে? So same sentence may be different emotions, different pitch pattern. Juncture I already given, I mean pause. Like in introductory talk I mentioned like a Rokomot Jane. The same, I mean example is for the juncture is mean physical pause. Okay. This is, you know, I mean you have heard this movie scene, very famous scene. But it's a very important, I mean, scene. I just playing. I don't know if it's clear or not. Maybe not. Okay. So the scene is something like that. Amir Khan is with the prison, and Amir Khan is trying to say the acha, the word. The meaning is different completely. Acha. Acha. So I mean, why I'm saying one word, only one word, expression is different, meaning is different, meaning is different, context is different. Many things is possible in Indian language only. Understood my problem? So these kind of problem statement we have in Indian languages, if we try to resolve or try to take any kind of, I mean, thesis problem in such a way, the same word, same, only one word, expression is different, intonation is different, entire context is different. Okay? বাংলায় একটা কথা আছে লুচি, you know the লুচি, আমরা খেতে সবাই ভালোবাসি। One ISI, Indian Statistical Institute scientist or researcher, they have prepared one sentence with the word luchi. And he prepared the different sentences on the word of luchi only, Bengali. And he published his thesis. Understood? So you try to understand the problem very well. Then only one word can give you SCI journal, 5 SCI journal on the luchi word only. Understood? So each and everywhere, if we are talking about the problem in audio signal processing, huge. Though we are already seeing like Google already, our deans are already mentioned in Google speech to speech translation is there, but there are some errors are already there. Researchers are working, but it's a small thing not yet resolved. If you think there are many things we can provide, we can work on this problem statement. Okay, perception is basically opposite. Like I am trying to produce, so it is a production point. Perception, my ear is mostly responsible, and my ear is a non-linear in nature. It's a non-linear in nature. Okay. I'm not going to the detail. There are so many things. Only thing I'm trying to say or convey, our ear cannot listen all sound. We cannot perceive all kind of sound, though we are producing. What is that? Fly. They are also producing some kind of sound, but sometimes we listen, sometimes no. Mosquitoes, they are also producing sound, but sometimes we can listen, sometimes not. So our ear can understand only frequency range maybe 16 kilohertz till 16 kilohertz, maximum 20 kilohertz. After that we cannot listen anything. After that we cannot listen anything, any sound. If I produce 121 kilohertz signal, normal sinusoidal wave, you cannot listen anything. Whatever the intensity of that sound. So it's a problem of our ear. I mean, not the problem, because God is prepared our ear in such a way, whatever, but if we can listen everything, আমরা তো পাগল হয়ে যাব। So FM they are also producing, and I mean they are transmitting the FM signal. So it's a transmitting here also. Here and there are different signals are there, but we cannot listen. We cannot listen through our ear. For that, we have the different receiver we designed. Our radio, they have their own receiver. I mean, perception device, so that we can listen. Understood? So there is a, I mean, if you there is a one beautiful examples in the YouTube or somewhere. You just search perception test, and this perception is also age dependent. I mean, like if I am at the age of little between 20 years to 30 years, I can listen 20 kilohertz, till 20 kilohertz. If my age is more than 60 years or maybe 70 years, I cannot listen even 10 kilohertz in a minute. I can impair it. We come whenever we are age enough. Like our grandparents, sometimes they cannot listen all the time. I cannot listen. There are some problem in the perception. কানে কিছু একটা প্রবলেম হচ্ছে, তাদের শুনতে পাচ্ছে না, ড্রামটা কিছু প্রবলেম হচ্ছে। So these are the problem. Okay. So understood now what is the perception? It's a non-linear in nature. We cannot listen the sound more than 20 kilohertz. Even more than 15 kilohertz is little hard to listen. I mean perceive. A brain is obviously is important. I mean whatever we will listen, we act accordingly. Okay. Skip. Oh. That is another importance of the perception in speech technology. Okay. So try to play some audio file. Can you understand? Which language? Huh? So it's a very difficult to understand the language itself, though we know the language. It's a Bengali, but it's really hard. It's a machine-generated synthetic voice. Nobody speak this. This is machine-generated voice. So our ear is not so comfortable with this voice. Agree? Okay? That's why we call it a flat, no intonation, no prosody. It's an emotion. There is no emotion. Okay? And this is intonated. It's a soothing for ear to be. Understood? So these are the two difference. Okay? This is again system performance.
Welcome to Kolkata. Welcome to Kolkata.
This is MP3.
Welcome to Kolkata.
It's a slight differences. It's a very difficult to perceive because of this audio system. If you listen using the headphone, whenever we will do the compression, we also, I mean, compression, we also reduce, and some kind of important features are already removed. Remove some important features whenever we compress from the raw data to MP3 compressed data. Acceptability, original, okay.
করোনার প্রধান রোগগুলির নাম বলুন।
Okay.
করোনার প্রধান রোগগুলির নাম বলুন।
Some noises already introduced intentionally within the audio file, and you have some difficulties to understand the actual audio data. Same sentence with noise only. It's a synthetic noise introduced in the original data, and it's a very difficult to perceive as well as difficult to understand. Okay, but we are intelligent enough. We can separate the noise and audio data. Our brain can do. Each the system can do the same thing. If I provide this original plus noise data to my system, you just write one example and in program. Tomorrow you just record your own voice, okay, and you fit white noise or Gaussian noise, any noise, you just fit and add in the audio file and try try to, there's a noise and audio you try to diarise. Okay, so you try. So that is one problem. Okay, you can do.
Welcome to Kolkata.
Sorry.
Welcome to Kolkata. রাজবাড়ী খাওয়া দিয়েছিলেন বহুজাতিক তথ্য প্রযুক্তি সংস্থা কর্মী সুষময়
Sorry. Some problem perception. So too many sounds. I cannot remember which sound I prefer. I give the priority to listen. Okay, same. What is the feature? Feature a measure of a property of speech waveform. Reason of the extraction. What is the reason? We try to extract the unnecessary information from the audio data. Unnecessary information. What is unnecessary? Everything is necessary, we thought, but not. You know, I already mentioned that vowel or voice-like sound, they have the more energy and more information. Okay. Every time we try to reduce the consonant part automatically, not all, but like shh, this kind of sound is not required. It's a noisy sound. Maybe we can reduce, but you need to write a program in such a way so that it can distinguish the voice sound and unvoiced sound automatically. How much time? How much time, sir? Over?
It will be started late.
Oh, okay. How much time? 5-10 minutes? 12:45. So how much time I have?
Sir, actually we started late. Your time is up to 12:30. From 12:30 to 1:30.
So anyway, for the time.
You have another session. You can continue after because
Just,
Sunday is very much.
I'm just concluding my talk here. I mean, what is a feature? Features is the way how to extract the major information from the audio data. Okay, that is the entry point of creating the raw data to create my CSV file. Okay, this is the entry point. So there are different features of the audio data from low level to high level. We need to extract. I mean, it's also depend on your application. If you are planning to develop like a speaker recognition solution, your feature is different whenever your problem statement is a speech recognition. So what kind of features you try to extract from the audio data, it will depend on the problem statement only. Okay, I'm just skipping. And these are some mathematical way how we extract. One important features we call is the MFCC features. Male frequency cepstral coefficient is a very important feature. If you search anywhere in the, speech feature extraction, this will come fast. Okay, so I'm stopping here up to these features. So maybe in this next session we will do some kind of exercise in hand. Okay, so after that some kind of application that we will take later. Okay, thank you. Any question or any suggestion? So any feedback? So any question? Any basic question also? Never mind. I mean, you did not ask a high-fi question. I'm not here. I am also not able to understand those questions. If you have any basic question, I try to answer those questions. If there is no question, maybe after some